Six Sigma DCX allows you to plan a high-density deployment in an operational data center using predictive simulation. We begin with a virtual model of a raised floor data center, which includes all IT, power, and cooling infrastructure in the facility. Looking at some high-level plots can help inform an ideal deployment location. This image displays present-day cabinet loads, showing some empty racks and others loaded up to 8 kilowatts. By simulating this configuration, we see that currently all cabinet inlet temperatures are within ASHRAE recommended guidelines. We can also look at design IT limits for each aisle in order to see where there is available power. Aisle 3 appears to be the ideal location for a high-density deployment. There are some open frame racks in the facility inventory that can be tested in this deployment scenario. Taking a closer look, the planned deployment is for 5 15 kW racks, which is much higher than the average per cabinet load in the room. With the racks installed, the model is set up and ready to simulate. Checking cabinet inlet temperatures for ASHRAE compliance, the HD racks appear to be within recommended guidelines, but cabinets in the aisle over are overheating. Animating the inlet airflow to overheating equipment shows the source of the problem. The high volume and high velocity exhaust from the HD cabinets is flooding the racks in the neighboring aisle. So although there is enough cooling in the room to support the high load deployment, there's an issue with managing the heat it dissipates. Knowing this, we can switch from open frame racks to self-contained racks with top vent exhaust. By running another simulation, we see that cooling performance plummets. The HD racks cannot be supported in this configuration. However, it can be helpful to understand why the deployment doesn't work. In this case, the pressure buildup at the back of the rack is too great, and hot air is leaking out of gaps in the mounting rail back into the IT equipment. It's possible that installing fan-assisted chimneys could help reduce the pressure buildup in the racks and more effectively remove IT exhaust air. Running one last simulation, we finally are able to show all cabinet temperatures are within ASHRAE guidelines. We've successfully planned the deployment. Taking it a step further, we can even assure that chimney fans are properly sized for the cabinet load. Wrapping things up, we've seen how modeling can provide insight to help troubleshoot a difficult deployment, empowering users to more effectively solve engineering problems. Please feel free to contact us to learn more.